Hello, Math 1020 class. Let's do the Chapter 5 review. The purchasing power decreases if inflation is present in the economy. For example, the purchasing power of R dollars after 2 years of 6% inflation is given by the following model. What will be the purchasing power of $60,000 after 15 years of 6% inflation? Well, in this equation, P stands for the purchasing power, R stands for the original price of the item. So in this case, it would be 60,000. And T is just the number of years after the present. So it says after 15 years. So we would just plug in 15. So the purchasing power is going down. So what was worth $60,000 will be worth this much 15 years later. That's the idea. If an earthquake has intensity 45,000 times I0, what is the magnitude of the earthquake? So here is the magnitude of the earthquake. This is the definition. I is the intensity of the earthquake. I0 is the intensity of a very small earthquake. But it says this particular earthquake has an intensity 45,000 times I0. So you just have to replace that I with a 45,000 I0. And notice your I-zeros cancel, so just plug the rest into a calculator. That's a common log, by the way. And I get 4.7 to the nearest tenth. Solve the log equation. Log x to base 4 equals 1. Well, remember the trick on these is to change to exponential form. So start with a base and go in a little circle. 4 raised to the first power is equal to x. But that's really just the same as saying x is equal to 4. Solve the inequality. 3 to the x less than 2187. So I think I'm going to save that for the calculator video, because I want you guys to do that one with a calculator. Suppose the retail price of an automobile is $33,000 in 1999. And that it increases 4% per year. Part A. Write the equation of the exponential function in the form y equals a times 1 plus r to the t power that models the retail price of the car 2 years after 1999. Okay, so that's kind of easy. A is just going to be the original price of the car. And R is the percent increase in decimal form. So you just have to move the decimal to the left 2 places. And the T stays where it is. And this one is multiple choice. According to the model, was the retail price of the car in 2011. So just remember on this one, the base year is 1999, so that corresponds to t equals 0. So if you're looking for the t that corresponds to 2011, just subtract the base year from it. That's always the trick. And I get 12. So just plug in 12 right there. Actually, I guess in this one they wanted us to round to the nearest dollar. So that should be the answer. Well, let's do the next one. And I guess actually that's it for this particular chapter. So let's move on to chapter 6. Use the equation of the polynomial function to complete the following. So this should be some of the stuff that we've done recently. Part A, state the degree and the leading coefficient. So remember, the degree is the highest power of x. That's just 3. The leading coefficient is the coefficient of the leading term. So that's the leading term. The coefficient in there is -2. Describe the end behavior of the graph. Well, you just have to look at the leading term. What does the leading term do as x goes to plus or minus infinity? Okay. Well, when x goes to plus infinity, just imagine plugging in a huge positive number for x, like 100. So when you cube it, it's going to be even bigger in positive, but when you multiply by -2, that turns it into a huge negative number. And if I plug in a huge negative number for x, well, that cube is just going to keep it negative and big. And when I multiply a huge negative number by -2, that actually turns into a plus infinity. So roughly speaking, when x goes to plus infinity, that's over here, the function actually goes down to -infinity. And when x is close to -infinity, which is on the left there, the function goes up to plus infinity. So we don't know what it does in between, but we know what the end behavior is. And they ask us to pick the correct graph. There's only one graph that you're given that has the correct end behavior, so you don't really even need to put that into a calculator. Alright, number 2 looks like another calculator problem. So I will save that for the calculator video. But let's do number 3. This looks like it's from the very last section, 6.5. Find the equations of any vertical or horizontal asymptotes of this function. So let's start with the verticals. And remember, the trick is to set the bottom equal to 0 and solve for x. So this one just has one vertical asymptote. Now, what about horizontal asymptotes? That's part B. Well, remember on this one, you're supposed to look at the degrees. 6 is really the same thing as 6 times x to the 0. So the degree of the top is 0, the degree of the bottom is actually 1, because that's an understood 1 there. And whenever the degree of the top is less than the degree of the bottom, y equals 0 is your horizontal asymptote. And you want to make sure that you write that as an equation. If you just put a 0, it's going to mark you wrong. Put y equals 0. So for the vertical asymptotes, it's always x equals constant. The horizontal asymptotes are always y equals constant. Make sure you put it in that form or it'll mark you wrong. Here's another one. Same instructions. How do we find the vertical asymptote? Set the bottom equal to 0. Solve for x. So I would add 49 to both sides and then take the square root of both sides. So one of them is x equals -7, the other one is x equals +7. That's two vertical lines. And you have to put them in order when you key it into the computer, which means the -7 comes first. What about the horizontal asymptotes? Let's take a look. Well, notice the degree of the top is 3, the degree of the bottom is 2. Whenever the degree of the top is bigger, there is no horizontal asymptote. This last one is a rational equation. Again, this one is from 6.5. Okay, so the trick is to multiply both sides by something that's going to cancel this out and cancel this out on the bottom. So obviously what you want to multiply both sides by is x minus 1. So I'm going to put the left side in parentheses, multiply by x minus 1, and then put the right side in parentheses and multiply by x minus 1. So when you multiply these two together, just keep in mind the x minus 1 is on the top, so that'll cancel these two out, and I'll just get 6x squared plus 1. But nothing cancels out in the second product. It's just x minus 1 times x. And on the right-hand side, that's x minus 1 times 7. But in the second product, they cancel out, so you just get a 7. And notice I'm distributing now. Distributing that x from right to left, and I'm distributing that 7 from right to left. Combine like terms. I guess at this stage I want to subtract 7x from both sides. So I'm guessing this thing probably factors. 7x and x, I think those are about the only two terms that will multiply to give you 7x squared. 1 is easy, it's just 1 and 1. You just really have to get the signs right. Well, the outer is 7x, the inner is 1x. Can we get -8 out of that? Yeah, if they're both negative. And you can double check if you want to, if you FOIL it. The first is 7x squared, check, minus 7x minus x, that's -8x, plus 1, so it looks correct. And then once you factor it, set each factor to 0. The second one is a little easier to solve, but in the first one I would add 1 to both sides and then divide by 7, so 1/7. So these are the two potential solutions, but remember you can't have extraneous solutions when you solve a rational equation. Let's try 1 first. Does 1 check out? No, because 1 will make this 0 on the bottom. You can't divide by 0. So the 1 is extraneous. What about the 1/7? 1/7 is okay. It doesn't make that 0, and it doesn't make this 0. So 1/7 is the only solution. So that should do it for this video. And again, I will make another video that shows me doing some of these other problems with the calculator.